So hello everyone, this is lecture 63 for the mathematical physics. In this lecture we will study the Green's theorem, and that will be your last topic for the vector analysis. So let's see. Green's theorem is nothing but Stokes theorem in the two dimension. So if you apply the Stokes theorem in the two dimension, that will give you Green's theorem. Let's see what the Green theorem says. So if there is any surface in the 2D and region R, and this contour direction is given anti-clockwise, and vector field is given in two dimension, that is xy equal to sum in form of px cap and qy cap. P is function of xy and q is function of xy. So vector field is given in this way. Then you can write this p dx plus q dy equal to del q by del x minus del p by del y dx dy in this region. So see, if vector field is given in this form, means p dx plus q dy, then you can directly solve this result using this formula. Take the del q by del x minus del p by del y and dx dy will give you value of this integral. So fxy is this, is a 2D vector field. Let R be some region in xy plane and C is the boundary of that region oriented counterclockwise. So if it is anti-clockwise or counterclockwise, then it will be positive here. When it is going clockwise, then you will take negative here. Okay, so this is your statement for the Green's theorem. Now let's see how we get this theorem from the Stokes theorem and how we can say that this is just a Stokes theorem in 2D. So let's see, we know Stokes theorem, that is del cross f dA equal to f dot dl, line and surface. Now we know in 2D dl will be dx x cap dy y cap, and f is in this form. So f dot dl will give us p dx plus q dy, and this contour, so f dl will be equal to this. Now let's find the left hand side of the Stokes theorem, that is del cross f dA. So del cross f will be, can you find it from here? So x cap, y cap, z cap, del by del x, del by del y, del by del z, and in place of f we have pq 0 because z component is 0. So find this curl. So it will give you del by del y of 0 0 minus del by del z of q is 0, because p and q are function of xy and it is in 2D, that's why differentiation of this will be 0. Minus y cap, del by del x of 0 will be 0, del by del z of p will be 0, plus z cap. Now del by del x of q is as it is, del q by del x, and it is del p by del y, z cap. Now we have del cross f, and dA in the 2D plane will be dx dy z cap. Now del cross f dot dA will give you this multiplied dx dy. So see, this is equal to this, and this right hand side of Stokes theorem equal to this. So we can write this equal to this from the Stokes theorem. So this is your Green's theorem derived from the Stokes theorem. Now let's see some examples how we use this theorem. So if it is given, we need to find this integral 2y dx minus 3x dy, and this contour will always be given. And see, from here you can also see this contour is in clockwise direction. So this is a circle, and p here is 2y and q is here minus 3x. So you know the formula, just find the del q by del x and del p by del y. So del q by del x will be minus 3 and del p by del y will be 2. So minus 3 minus 2 will give you minus 5. Substitute here and it will be r minus 5 dx dy. This minus because this is clockwise. Now this will go, 5 will go outside, you have dx dy. So you can directly write the area, because this dx dy represent the area of this curve. And you know this is circle, so it will be pi r square, directly you can write. And r can be 1 here, r is 1 here. Okay, so you can directly write pi r square where r is 1, so you will get your answer 5 pi. And you can do it in the other way also, because this is the cylindrical coordinate system, this is polar coordinates you can say. So you can write in terms of r phi. So in the cylindrical polar coordinates, this area is nothing but r dr d phi. So you can see my previous lecture so to see that how we are getting r dr d phi for this area in the 2D plane. So it will be r dr d phi, where r is going from 0 to 1 and phi is going from 0 to 2 pi. So this will give you the same result, r square by 2 will be 1 by 2, and d phi will give you 2 pi, that will give you pi. So it will be 5 pi answer. Or you can directly say that dx dy represents the area, so pi r square, r is 1, so pi, then 5 multiplied pi will be 5 pi. So you can go both ways. Now in this 2D system you will always use either the Cartesian coordinate system or the cylindrical coordinate system. Okay, because you can't get a spherical here because this is 3D. So that's how. Let's see some more examples. xy dx plus x plus y dy. So this is p, this is q. So find again del q by del x, del p by del y. So it will give you del y. This will give you 1, and del p by del y will give you x, so 1 minus x. Now 1 minus x dx dy. Now see, again this is a circle, so you can represent it in the polar coordinates and cylindrical coordinates. This x is nothing but r cos phi, y is r sin phi, and dx dy can be represented as r dr d phi. So in place of x, write r cos phi. And now limits will be r is going 0 to a and phi is going from 0 to 2 pi. Now this is simple integration you can solve. So first we will solve for the r, so it will be r here and r cube by 3 here cos phi. Put the limits for r 0 to a. Solve this. Now for d phi it will be phi here and sin phi here. Put the limits 0 to 2 pi, it will give you this. So again this is same pi a square. So use this method always. Let's see some more questions. So x plus y ds minus x minus y dy. So what is this value? So it is here p is x plus y and q is x minus y. Q is minus x minus y. Okay. And the contour is some way this way. Reason is this. This is ellipse. Okay, ellipse is given. This is A, this is B. Now we need to find. So P is x plus y, Q is minus x minus y. So find del Q by del x minus del P by del y. So del Q by del x will give you minus 1 and del P by del y will give you 1. So it will be 1 minus 1 minus 1. It will give you minus 2. So I will be minus 2 dx dy. Now see, this dx dy represents the area of the curve. And we know this is ellipse already. So we can directly write the area, that is pi AB. So that will be your answer. Now the next example, let's see. I is this and this direction is anti-clockwise. So x square y dx minus xy square dy, and figure is, reason is this circle with radius a. So find again, p is this, q is this. So del q by del x will give you minus y square and del p by del y will give you x square. So minus y square minus x square, put it here, dx dy. Now again this is circle, then use the cylindrical polar coordinates. So dx dy will give you r dr d phi. In place of x it will be r cos phi, y will give you r sin phi. Now take the minus r square and this r also. Take the minus r cube common. So it will give you cos square phi plus sin square phi, that will be 1. So minus will be outside, minus r cube dr d phi. So put the limits for the r, then for the phi. So for the r it will give you r 4 by 4 and for d phi it will be 2 pi. So this will be your answer. Let's see one more question. So it is sin x minus y dx minus sin y minus x dy. So this is p, this is q. Again find the del q by del x minus del p by del y. So del q by del x will give you minus plus 1 and it will be minus del p by del y will give you minus 1. So it will be 1 plus 1 because of this minus. This will be 2. So 2 dx dy. Now again this represents the area. So area of the circle is nothing but pi and radius is 1. So it will be pi r square. So 2 pi will be your answer. You can solve using cylindrical coordinates, you will get the same answer. Then radius will be 0 to 1 and phi will be 0 to 2 pi and dx dy will give you r dr d phi. So you will get the same result. Let's see one more question, that will be your last. I equal to contour C and x square minus y square dx plus 2xy dy, where C is boundary of R. Now what C is here. So these conditions were given. This figure was not given, only this was your question. So let's see how can we draw our figure from these conditions. Where C is boundary of R, x, y are such that x is going 0 to 1 and y is going 2x square to 2x. So there are two functions given, means x will be 0 to 1 for both of the functions and y will be between 2x square and 2x. So for the y equal to 2x, this will be your line. This will be your line and this region will be lie inside this region. Now for the y greater than or equal to x square, this will be for the parabola and this will be your parabola curve and it should be greater than this. So the intersection of these curves means the curve means the region less than this y equal to x and the region greater than this y equal to x square will be lies inside this. So for this will be your region and x is lying between 0 to 1 only. So only this is your contour. Okay, and this will be your direction. So now we need to find for this we need to find this integral for this contour. Okay, so let's see, p is this, q is this for this. Now del q by del x will give you 2 pi, del p by del y will give you minus 2 pi. So I is nothing but r 4 means again this is minus 2 pi 2y. So it will be 2y minus plus 2y will give you 4y. Del q by del x minus del p by del y, that will give you 4y here and dx dy. Now see, here x and y are depending on each other, so we need to put limits according to that. Okay, so x is independent variable, that is going 0 to 1, but y is depending on x, so that is going from 2x square to 2x. So this will be your limit. Now solve for this. Y dy will give you 4 taken outside because this is constant, so it will give you y square by 2, and limits for y square by 2 will be 2x square to x 2x. And after substituting these limits, then take the integration with respect to x and substitute the limit 0 to 1. So this will be your answer. Means first this will give you your integration, then take the integration of this also. It will give you x square will give you x cube by 3, x4 will give you x5 by 5, and after substituting 1 and 0, so it will give you 4 by 3 minus 4 by 5. Solving this will give you 16 upon 15. So this will be your answer. So that's all for the vector analysis. Remember this thing, that when you do these calculations in Green's theorem, so you will use either the symmetry of the Cartesian or the cylindrical. Okay, so that's all for today. In the next lecture we will start some special functions for the mathematical physics. So thank you everyone.